Okay, we're up and running. Good afternoon, Joseph. Got your text today. So I have it just so happens that I had a copy of the McDougall-Littell geometry book. And today we're going to look at 4.2 angle measures of triangles. And I'm going to try to burn this out in about 10 minutes so I don't bore you to tears. So far you did the triangle sum theorem. Okay, so one of the big things, say you have this triangle ABC, and just for fun, let's review a little bit some of your vocabulary. So this is angle A here is an acute angle, meaning that's less than 90 degrees. Angle C is also acute, its measure is less than 90 degrees. And angle B here is obtuse. Its measure is greater than 90 degrees. But the big thing here is we want to talk about what is the sum of A plus B plus C. And you probably had this in class, but since I wasn't there, I'm just going to go for it. So if you add the measure of angles A plus B plus C, you're going to get 180 degrees. Okay, and we're going to prove that a little bit here. I'm going to pause for just a second. Okay, Joseph, I took a little break to draw a triangle in Geometry Sketchpad. Now, right here, right here, right here, I have the measures of the three angles. And as I drag A around, you'll notice that the measures change for all of them. So I want you to get out your handy dandy calculator, and you may need to stop the video. Anyway, like let's say right there, I want you to add up the measure of angle CAB plus the measure of angle ABC plus the measure of angle ACB. That's the three interior angles of this triangle, and see what you get. So stop the video and check that out. Okay, so did you get 180? You should have, or something really close to it. It might, maybe a little bit of rounding error. Maybe you got 179.99. So if I drag point B around, now we have a measure. Well, I didn't want to drag that. I want to drag that there. Now we have a measure of angle ABC is 32.95. And then plus the measure of angle CAB is 51.05. Plus the measure of angle ACB is 96 degrees. If you add these three together, what do you get? Pause the video if you need to. And it should be 180 degrees. So then lastly, I'm going to drag this one around, and these change. And one last time, add the measure of ACB plus the measure of CAB plus the measure of ABC. And you should get 180 degrees, showing you that the sum of the interior angles of any triangle equals 180 degrees. So we're 4 minutes in, doing okay. We better keep going though. So we did the triangle sum theorem, very important, and that's in your book on page 179. And you'll use that all the time. Corollary, oh, that's silly. Yeah, that one's not so bad, but it's okay. I'm going to skip that one. Exterior angle theorem. This one is good. This is a good one. Let's do a new and better triangle that looks like this. And this applies once again, Joseph, to any triangle. That part's cool. All right, so just to be safe, I'm going to group these guys so that it'll stay together. Come on. Why is this doing that to me? Technology is supposed to make our lives easier, and it just is here to make me crazy. Okay, we have these together. Maybe I'll make it a little bit bigger so we can really see it. Now, the whole idea here, I need a protractor. Okay. The whole idea here is that if you measure this angle right here, this cat here, and you can label it if you want to, it doesn't matter. So I want you to measure that. How much did you get? 0, 10, 20, 30, 40, 50, 60, 90, 100, 110, 120. Looks like about 125. Do you concur? Okay. So this angle here is about 125 degrees. Here's the good part. So this is called the exterior angle. Exterior angle. Okay, cool, man. Now we talk about the two remote interior angles. So that's going to be this one and this one. Remote interior. There's two of them. Okay, so this is where it gets really good. This one's nice. Okay, so we had about 125 there. We're going to go in here and measure this as well. In this, there will be some error here probably, but we'll do the best we can. Come on, right about there. Okay, now, what's the measure? It looks like 10, 20, 30, 40, 50 and change, maybe 51. Maybe 51. Will that let me write on there? No, I got to move it. So that one's 51 degrees. Now let's measure the second remote interior angle. I'm going to go up to there. We got to turn this thusly. We'll put that there. We got to turn this a little bit more. About there. And what's the measure this time? 10, 20, 30, 40, 50, 60, 70. What is that? About 74 maybe? Okay, and back up the video if I'm going too fast. 74 degrees. Now here's the cool payoff, Joseph. Notice anything interesting about 125 degrees and about 51 degrees and 74 degrees. What did you notice? Pause the video here if you need to. Did you notice that 51 degrees plus 74 degrees is equal to 125 degrees? Cool, man. I'm here to tell you that's cool. Okay, so let's check it another way. You don't believe me? That's all right. You can be a doubter. It's all good. Okay, let's check it another way. If I go there and there, and then I group these two. I'm going to group this. I need my mouse. Got that. Got that. Going to group it. Group it. Going to clone it. Okay, so I'm going to rotate this around. And I'm going to bring it into this remote exterior angle. See what I'm doing? Okay, then one more time. I have that one. And another color. I don't want to use black either. It's too hard to see. Not there. I can fix it. We have the technology. Make it blue. Okay. Then I think I'm just going to clone that one too. Bring it up to there. Bring that one down. Bring that one to there. group them, clone them. Okay, now I'm going to bring this one in. I want you to notice, Joseph, that will slide right in there, and that the two remote interior angles, in other words, this 51 and this 74, are congruent to the exterior angle. I don't need my protractor anymore. And that's wicked cool. Wicked cool. I can tell you're rolling your eyes right now. 74. And together, they equal 125 degrees. 125 grados. Cool. And they are congruent. So we just did the exterior angle theorem, which is on page 181 in your book, if it's the same book. I think it is. Let me know. Page 181, exterior angle theorem. Okay, cool, man. All right, so we have that. How many minutes are we up to? I don't want to bore you to death. Ooh, we're past 10. I was hoping to do it in 10. I want to do just one more thing, and I'm sorry, we'll do it in under 15, but this is important. So if we grab a triangle, any old triangle, and I don't know, maybe it needs to look a little more, yeah, whatever, that'll work. If we grab a triangle, and if we label these guys A, B, C, and if we label these in terms of variables and angles, not just numbers of degrees, not just the measure in degrees, we call this x degrees, and if we call this, I don't know, 3x, does that look about 3 times as big? And then if we call this other one, I don't know, that looks a little bit bigger. X plus 30 maybe degrees. Looks bigger. Maybe it's smaller, I don't know. Just guessing. Let's just say not to scale. I made this one up. But the big thing is, you learned from your triangle sum theorem that the measure of x plus 30 plus x plus 3x equals how much, Joseph? Come on, tell me. You're right, 180 degrees, because the sum of the interior angles of all triangles has to equal 180 degrees. That's the deal. So if we know that x plus 30 degrees plus x plus 3x equals 180, we can algebraically solve for x and know what these are. So how many x's do we have? Well, degrees. Here's 1, here's 2, here's 3. 1 plus 2 plus 3 is 5x plus 30 equals 180. Okay? Now, what's the next step that you're going to do, Joseph, to solve for x? Yeah, you thought you'd never have to do algebra again. Okay, you're right. You're going to subtract 30 degrees from both sides to keep this equation balanced. And bring down what you haven't used yet. Okay? So now we have 5x equals 150 degrees. This is going to come out nice, I can tell. So 5x equals 150 degrees. I'm going to write that a little tighter. And how are you going to solve for x when we have this coefficient of 5 right here? You're right. You're going to divide by 5 there. Whatever you divide by 5 there, the division property of equality tells us we have to do the same thing on the other side of the equal sign. That leaves us with x equals What's 150 degrees divided by 5? Well, that's 30 degrees. And we're done. And life is good. Let's see how far we got. We kept it almost under 15. Joseph, let me know if these are helpful. If they are, I will make more. That is all. Have a good night, young man.